later on, but now just Q and R you take, and here you see, here this line is inactive, but you can open it now to calculate the gain K1. And here you see DARE we are using based on 4 things. What are the 4 things we have given to the DARE? That is AS, BS, Q and R. With that, you open these figures and see the result, that whether this gain is working to stabilize this system or not. But for that you need, and now I am moving what I have done. We have separated the program for case 1, case 2, not the whole thing. Now I am showing this one. You see, this case 1, only I kept whatever is required. You can do also that one. Whatever the first problem to solve, whatever the codes are required, that part only we kept. Rest of the things we have deleted, but for you, if you do not want to delete, just you make it comment. That's all. And you see whether it is working or not. Rest of the things to you, you do it and tell me that whether your code is running. And here only one thing I am telling you to do this. You see this line. This line I make it open, but I kept this K1 comment, and here I am declared K1. Okay, the gain of the controller. And now with that gain, we are applying this gain to the system, and then we are doing the plot, and you see that what kind of plot you are going to get, whether the system is stabilized or not. Okay, done? You will find that if I will run, you will find that the 4 states here, you see K1 is calculated by MATLAB, and this is the states you are finding that it is converged. Okay? So rest of the things I will not tell. This is the first thing I told you. Now you will find that in the same program, case 2 is also there. You see how the case 2 is formulated, okay? And then subsequently you try the other modules also. I will help whenever it is required, but try to do by yourself only. And my advice will be to split the program, case 1, case 2, case 3, case 4, case 5. You see, I have splitted the program for here. If you see, case 1, this is for my case 2, this is for my case 3, this is for my case 4, and this is for my case 5. Okay? And other auxiliary files must be inside the folder of each cases. Don't delete it. Okay? Fine. So let us do. And let me see. Before doing the things, one thing I just wanted to tell you, just you try to understand. You see, when you are going to do the number 3, what it is saying that simulate the NCS with random delay and packet losses using suboptimal control, which uses the mean value of delay to calculate the system model AZ and BZ. Okay. So, can you remember in Sir's slide, Sir told that when you are going to consider the random delay and packet losses, how to calculate the A-B matrices? Can you remember that? I will show you. For your convenience, I will show you that where it was. Let me show you such that you can recollect it and you can do it. Then only you will able to understand that the correlation between this program and whatever the theory has been taught in the class. You can also find it, then it will be easy for you to understand. Oh, it was in introduction only. I saw that one. Now I can remember it. Yeah, this one. You see? how to calculate AZK and BZK considering the delay and packet losses. Okay, this formula will be useful. Then only you will able to know how the D bar is defined in your programming. Everything you can able to know that how to calculate. Suppose you have here, this is the particular slide I am talking about. This is a very important slide for, I think, every problem you will encounter later also. Okay, so x dot equal to ax plus bu, and then after incorporating assumption and considering the wireless imperfections including the delay and packet loss, the NCS can be represented by this. And now you see how the AB matrices are calculated and what are the other parameters are there. Because exactly this thing has been done in programming also, to calculate whenever the packet loss and the delay is there, how you will calculate the AB matrices for that case. And ultimately you will find that this will be the augmented state. That augmented state is also you will find in the program, that xk transpose, then uk minus 1, then uk minus d. Okay, so d bar. So these are the augmented states. So for your case also you will find that augmented state we have declared, and we have calculated azk and bzk formula. You just check it and see your program how this particular AZK and BZK is calculated there for the problem number 3. Problem number 2 is not a problem, you can do that one. Okay? So now you continue to do the problem 1, 2, 3 subsequently, and you will find that hint is given inside the main program only. Every cases are distinguished, only you have to understand what is required, what is not required to run that particular case. Do it. So this is the thing I am talking about. You see, generating NCS augment state system model AZK and BZK. Okay. So this is the way we are calculating, incorporating the delays and packet loss to have the AZK and BZK. ये अभी I will request you to see the corresponding slide also, because you see all the theories you cannot remember. So side by side you consult the particular slide, you try to identify that which slide is important for you to understand that particular program. Then only it will be clear to you. Take your time, that is not an issue. But And another important thing you see, if you want to do the last part, this slide will be useful for you. You see, if you want to do that, simulate the NCS with random delays and packet losses with optimal control, basically this one we want to implement the Q learning based adaptive optimal control. That is the final goal. If you want to do this one, then you require this slide. I'm telling you which one. That is the Lyapunov stability Sir has shared or I have already shared. This particular slide will be useful where you see how this Q function has been generated. Q function has been generated, and this is the formula has been used there to have the Q learning algorithm. Okay, so this will be useful for you. Here you read this particular assumption that Q function, how it is linear in parameter, LIP. If you read this paragraph, it will be sufficient to solve that particular problem, because here whatever the way the weights are taken, exactly the same way the weights are defined in the programming also. Because if you see the weights to be chosen, here you see the hint has been given. What the hint has been given? You see, select the regression function for the Q function W1 square, then W1, W2, and you will find that one additional that is file is there in that folder where this function's regression function is defined. Okay, so that you can identify. So I'm keeping this particular slide open such that you can have this. If you
function is activation vector.
Yes, exactly. You see, these W's are required to be defined, and that is defined in their activation function. Yes, that is the model-free Q learning, where the models are not known to us. Those who came late, for them I am telling you, MTech people, you will find that we are dealing with the problem 1, and your MATLAB folder, you will find that one problem 1 folder is there, where you open the M file related to problem 1 only. Other are auxiliary files. Main file is the problem 1. And there you will find that the whole program is segregated with different cases. Case 2, case 3, you see. You split that. According to the assignment 1, you see it has been written that first you do the programming only with the discrete LQR. So you split the program case 1, case 2, case 3, case 4, case 5 from the main program, that is problem 1. You will find that it is all the programming are merged there. You have to split it by understanding. Any unstable case you are finding, or all cases you are finding that the system is stabilized?
So far we have seen
Two cases, okay, fine. Case 3 you go. Very good. Case 2 is also you will find that it is stabilized. Yes, good. Then you go for the case 3. Yeah, same. Yeah, that's why in your programming it is written whatever the k you have calculated in the one, that same k you use for the solving problem 2. Means the case 2. And I will advise you, if you find new command, what you have not known earlier, you take the help of MATLAB to understand that. That will be a nice thing, that you are going to learn a new command, what you have not used earlier. Several new commands you will find in that particular problem. Okay, 1 second. No, here actually you will find that here this is the delay year initialization. Yes. Yeah, this is the problem. Yeah. Yeah, exactly. So you make it off and you see now that what is going to happen. And yeah, I really didn't do that exercise because I thought that you people will play and you will see that what is the effect of that. Okay. And even if it is not done immediately, you can go back and you can see that one. That is the thing. Okay. But I want that whether you are able to understand the logic behind whatever the sir has taught or not. Okay. That is required. Okay. Stable. Okay. Case 3? Yes. Fine. They did. Case 3 already they did. So, yeah. Then you do the other two, 4 and 5, the last two. And I'm telling you why this problem is required to be understood by the dimension wise, because you will find that same problem you have to solve with different dimension in the next problem. So that's why you see that what are the things are required, what is the dimension you are using, just little bit of that idea you create. It will be helpful for doing the next programming.
So did you incorporate, so let's say, did you incorporate the relays and stuff here? You got it. And you change the dimensions of the vector and all. Okay, I see. Changed. You guys are smart. I think that is right. I think that's what they need. See, this is why we don't provide the program because one is when he and I were working on this, the students who wrote this code, they were doing it for the PhD and so they never commented on it. So it was not done for commercial purpose. Commercial I think you need to understand, yeah. It also helps you with MATLAB. Even if you don't know some commands, you can go back and, yeah. It's different. Each person has different style. Unless you run it, you probably don't understand the theory. You know, you always can go back and see what's happening.
And once the program is running, then what you will do, you will play with the parameters. Okay, then you will see that learning rate, if you change, what is the effect of that. Then QR, what is the effect of the weighting matrices. So these are the parameters you will change, and you will see what is the effect of upper bound of the delay. So these are the things you do and check that what is the effect in the system response. So I suggest you that you take a cup of tea, and because already 3 o'clock, and with that you continue. Okay. Hello? Okay, so I guess that how many number of cases you have reached? Up to case 4. So last one is the final one, that where you have to know that how the Q learning is working. But I need to know that whether the initial parameters and where the random delays and packet losses are defined. Have you understood that how it has been done? This part basically. Little bit here also you spend time such that you can understand that how the delay and packet losses are generated for this particular system.
Line 50, 51, the initialization of the T01 matrix. I mean, from line 50.
So that is required to calculate that the B matrix, BZK.
And the math equations are in the slide. I think that's what he said earlier.
Here you see how we are calculating. Some slide I showed you now that here.
Keep going back. And one more. Yeah, that's
Yeah, this is the formula.
lecture 1. But it's there in other slides also.
Yeah.
Lecture 1 is basically gives you the
Hello, sir.
Acha, okay. Shall I maximize?
No, no, sir, just follow the in the IS ma'am.
Okay, so for practice means now you need to do, because you see rest, if one program is clear to you, you will find the rest of the program is not that much, will be tough to understand, because I saw that it is similar way it has been solved. Okay, so whether your concept is clear or not, it will be understood if you now start to solve the problem 2. Problem 2 basically what we want, that same problem like problem 1. Here you will find that the continuous time batch reactor, here what is the dimension of A matrix? 4 cross 4. And what is the dimension of B matrix? So it is a basically MIMO system. Okay. So now the same thing means is this modular way what you have done to solve this batch reactor. I want that you should solve the same thing for the inverted pendulum also. Same way. You will proceed same way the inverted pendulum problem. Once again I am showing you. But now the thing is that the dimensions are different from the previous one. Here A matrix dimension is 4 by 4, but now you see the B matrix is, it is a scalar input we have now. Okay. So with this now exactly the same way what you have developed the modular programming for the batch reactor, case 1, case 2, case 3, case 4, case 5, exactly the similar way you will solve this one also. Then what will happen, that whether your dimension of vectors, what it is defined inside the program, it is clear or not, then it will be clear. Okay, so please you do it once you will complete the case 5. For the same thing you can copy, but you have to be clear that dimensions and the values you have defined correctly or not. And when you will do the Q learning, at that time you can use these parameters, that initial stabilizing policy, these are the matrices, or these are the values you can use, but regression function is same like earlier one what we have taken. Okay, and you can add the noise with a 0 mean and variance is 0.06. Okay, so this is the additional information it has been provided for the inverted pendulum, and you now try to do at least few cases you try. At least I am not expecting that you will do all the cases, but at least 2-3 cases you will try for this particular problem also. just go for that attendance.
should go up. Otherwise, it's supposed to go up. Because when you go up, this is happening losses to traditional options. So, if you don't want to do something, it's only using the original matrix. Yes, so that's the main reason. Now the question is, in order to control it, now you model it as and if you then you can find that before. But basically usually has delays and which is unknown. So then you have to use the proof. That's the second you don't know. And the dad, the problem one assumption is it assumes that I am process and all these days not really know. So this is mainly to show that the traditional arts like this is then I see the process doesn't know that I have to do this. It's not able to catch it. Because if it's looking at without the delay of the but I think you need to take pieces out and that's what how you're planning it. You need to take pieces and then just like what's the same, you need to take pieces to pull out the code and make it a system. If you run it, it will work. If you want to break it down, case one, stand alone. because the filter is on the other side, I never seen such a graphic. So he started with filtering on the base, so the system dynamics are not, that's what they say.
Anyone tried that problem 2? No? You're trying. At least case 1 you do for the problem 2. Case 1 is very simple. That's why I'm asking that can you do the for this the case 1 at least. Done.
Starting part of the code. Problem 1.
Problem delay is not required. Case 1 why delay is required? Just you discretize it.
No sir, problem 1.
Oh, problem 1. How the delay is defined?
The starting code at IND and underscore
Okay, here.
Yes, sir. Define the random delays, the first two lines, IND and underscore.
Basically, what I understood that they are actually having some bound of the delay. That's why here they are calculating that you see if you follow first they are defining the iteration, okay, and then after the iteration they are defining the ND, that is ITR by IND. That is that you proceed because number of I think that with the number of iteration it is important to have that relation. Exactly, I am not knowing that what is the relation, but we need to explore that one because that's why I am telling. Just you plug in and you see that ultimately at least for one step what is the value you are getting. Then only the things will be clear. What I am saying, you understood na, that just take pen and take the values and you calculate at least one step. You will find that the relation, it will be clear.
We have increased INT from 50 to 100.
Okay.
Then converting pen is increased.
Okay.
What is the relation? What does it
Signifies. Okay. Okay, I will look into it. That what.
And then the next one, n understood by dividing iteration by ND. Two lines only.
Okay, fine.
also I show case 2, D is within the sampling. So then I don't need that assumption. So those are things you will relax. But that's all. I didn't bring that copy, I didn't bring that, but I thought maybe I should just that deals with both deals with both you need also figuring it. So not only the quality of the system, but how do you select the figuring using the zero sum? Not zero sum, I think you have to also do regular naked. So these minimum sampling, also so optimizing the figuring so that you also place those. This is one of my experiments. So we have this one. This case one. And case one. So although I think also then what is the results?
Okay. You are getting the gain. Gain also?
Previously, gain was 2 cross 4. Here I have omitted that. Original K1 I'm getting. Vector 4 cross 1.
Gain also the dimension I have.
Minus K into X I have.
Yes, yes. You have that. Means it will be only a row vector. না এটা হচ্ছে অ্যাডমিসেবল কন্ট্রোল, মানে এটা এখন লাগবে না, ঠিক আছে, সেটা দিয়ে দিস ইজ দ্য অ্যাডমিসেবল কন্ট্রোল ফর কিউ লার্নিং ইট উইল ডিফাইন initial control what you have to define that is given this. So if you see the schedule, tomorrow second half there is no lecture, okay? Only the first half we have lecture. Have you seen the schedule? Okay. So can you tell that why we have not continued the lecture? Why suddenly second half is? Yes. So the second half has been given. You see all the problems we are not able to solve, and definitely whatever the question you raised, I will address you in either in WhatsApp. I will post that. Okay. If I am able to, I have to think that one. It will be I have to do that what exactly they wanted to say. And in the meantime, you will find that you will do this in the second half, tomorrow second half in your own place. You will try other programs, okay, and you will write what are the queries you have. And again maybe in the next tutorial session, some of the queries we will address first, then we will go for the new set of problems, okay. With that, we are concluding today, and have a good day, okay. Thank you.